So exponential functions, there are two types. The first one is exponential growth, and then the second one is exponential decay. For exponential growth, we see that when my starting value is positive, I have my graph go up, up, and become larger and larger as my x value gets bigger. So as x gets bigger, my y value gets much larger. The smaller my x value is, the closer it gets to 0, but it never crosses. When my a value is negative, so when my starting value is negative, I see that, again, it never crosses 0. It just keeps getting closer and closer. So if I extend this, it never crosses that line. But as my x value gets bigger, it gets further and further in this negative direction. Exponential decay, on the other hand, is the exact opposite. When my a value is positive, the y value is much bigger, the smaller x is, but as my x value gets bigger when I go along the graph, it gets closer and closer to 0. But again, it never crosses this x-axis. However, when my starting value is negative, my graph starts in this negative y direction, but as my x value gets bigger, it gets closer and closer to 0. But again, it never crosses. So when I extend these graphs, they're still just going to be closer and closer to that x-axis. Another main difference between exponential growth and exponential decay, for growth, my b value when I'm multiplying by is greater than 1. For exponential decay, my b value is between 0 and 1. So it's going to be a fraction between 0 and 1. So like 1/3, or we can have like 3/5, something like that. 3/2, on the other hand, would not be exponential decay because 3/2 is bigger than 1. So it has to be a fraction between 0 and 1. So let's look at some examples of determining whether each table represents an exponential growth, an exponential decay, or neither. So looking at this first one, I see that my y values are 5, 10, 20, and 40. So I want to first see, okay, am I adding something each time? Well, to get from 5 to 10, I add 5. 10 to 20, I add 10. 20 to 40, I add 20. For my x's, I'm just adding 1. So these are not the same, 5/1, 10/1, not the same slope, so it's not linear. So that means I'm multiplying by something each time. Here, I would recommend to figure out what that number is, to take your second number and divide it by your first. So if I take 10 divided by 5, I get 2. 20 divided by 10, I also get 2. 40 divided by 20, I also get 2. So here I am multiplying by 2 each time. So that means that this one is exponential growth. The reason why I know that, first I can just look at the chart. I see that my numbers are getting bigger and bigger. So that follows this graph here. As my x value gets bigger, my y value is getting bigger. I can also look at my b value when I'm multiplying by each time. It's greater than 1, so that also means it's exponential growth. Okay, let's look at the next one. So here, I'm going for 64, 16, 4, and 1. I can automatically see this is not linear because I know, like, to get from 4 to 1, I'm subtracting 3. To get from 16 to 4, I'm subtracting 12. Those aren't the same. I'm not multiplying by a number greater than 1 because it's getting smaller each time. I see as my x value gets bigger, my y value is getting smaller and smaller. It's getting closer and closer to 0. So that means that this one's going to be exponential decay. Now let's figure out what I am multiplying by each time. So 64 to 16, I'm going to do the same process like over here. I'm going to do 16 over 64. However, I'm going to get a fraction this time. So I could simplify that by hand, or I can go ahead and use Desmos. So I'm going to go ahead and head over to Desmos. And I'm going to put 16. I'm going to hit the slash button where that question mark is, and 64. However, I don't want a decimal. I want to keep this as a fraction. So when I click on this fraction button right here, it will change that to a fraction. So I see here I'm actually multiplying by 1/4 each time. I see if I do the same thing with 4 over 16, 4/16, I also have 1/4. And times 1/4. Okay, and then for this last one, I see for my x values, I am going up by 2. For my y values, going up by 7. So that means that this one is neither. Okay, that's it for this video, and go ahead and move on to that last one.